Let's try another one. We are going to write out our formula for integration by parts. We want to find the integral of f of x g prime of x. Then what we need to do is take f of x multiplied by gx and then subtract the integral of f prime of x gx dx. Oh, I forgot my dx over there as well. Now moving over to the next step, I'm going to write, I want to find the integral of x ex dx. And I put the equal sign, but now I need to assign each of these functions and maybe its derivatives or integral appropriately. So I'm going to just guess. Why don't I let f of x be equal to ex, and why don't I let g prime x be equal to x? And that means that f prime of x is just going to be equal to e of x, and g of x is going to be equal to x squared over 2. Right? Easy enough. I know how to find the integral of x. Let's go for it. Now I'm going to plug that into our formula, and so we get f of x is equal to ex times gx minus the integral f prime x, well, that's just ex, times gx, which is x squared divided by 2, and I write my dx. Now, what am I going to do? Well, I'm stuck. I'm totally stuck. I have no idea what the integral of ex multiplied by x squared divided by 2 is. I don't have a rule to find the integral of this thing or this thing. I don't know how to do that. So what's happened here? Well, integration by parts failed. It didn't work. Integration by parts isn't always going to work. And so choosing my f of x and g prime of x in this way, the integration by parts failed. What went wrong? Well, usually we want something in the right-hand side term, right-hand side integral term to cancel out. You know, we want something to be divided by itself, something or in general to be simplified. Also, when I chose g of x equal to x, or I should say g prime of x equal to x, g of x was equal to x squared 1/2. And that kind of made things more complicated. Which made the expression on the right-hand side more complicated, higher order term. And so integration by parts is hard. You can always find the derivative of a function. I don't think there are a continuous function that's differentiable. You can always find by definition really, you can always find the derivative. Here with integration, you can't integrate every single product of a function, product of two functions. It can't always be done. And it's hard. And sometimes you have to try a bunch of different ways, and it can take lots of work to try and integrate by parts. For our purposes, why don't we just do this again, except that I'm going to redefine my f of x and my g prime of x. So we got stuck this time. Let's see if we can try it the other way if we get a better answer. So how about this time f of x is equal to x, so that, well, that looks kind of good, right? Instead of getting x becoming a higher order term, it's going to become very simple. It's just going to be equal to 1. And integrating e to the x is really simple. It's just itself, right? The derivative of e to the x is itself, and the integrand is itself. Integral is itself. Now let me try this. So I've got f of x is x, gx is ex, minus the integral of f prime of x, well, that's just 1, multiplied by g of x, that's e of x, there, dx. And when I take this expression, now all I have to do is all I have to do here really is integrate the right-hand side. I'm going to get the integral of x ex dx is equal to x ex minus, well, ex itself. And I can factor out the ex, so I've got ex minus 1. What about my proof? If I want to double check and make sure I got the right answer. Uh-oh. Geez, never forget the constant. You see how bad I am. I lost lots of marks when I was an undergraduate student in calculus. I always forgot to write that C. No matter how many times I was warned by the professor, I always forgot to write that C. Now, the proof. So let's take the derivative of this thing with respect to x. So we've got ex, x minus 1 plus c. And that's going to be equal, I'm using the product rule here, so I've got ex, x minus 1 plus ex. If I open up the bracket, I've got ex, give myself a little room, it looks nicer if we got the x in front, right? And minus ex plus ex, x, ex. And that's exactly what we were looking to take the integral of. And so this is the correct answer. I didn't set up my equation properly the first time. I had to let f of x be x. If I tried f of x is equal to e to the exponent x, it didn't work, because this thing over here was too complicated. So I took a step back, I switched my f of x and my g prime of x, and then it worked out nicely for me, and I got the answer. Here's one for you. Press pause on the video, give it a try, use the formula for integration by parts, and see if you can get the right answer. When you're ready, press play, and we'll go through it together. There's my formula for integration by parts. I'm going to write down on the left-hand side the thing we're trying to integrate. So I've got x squared log x dx. Put an equal sign, but I can't go any further until I define what is going to be my f of x and what's going to be my g of x. So remember, the f of x, we want it to be easy to find the derivative of it. And since my choice is here x squared or log x, both of them are pretty good candidates for f of x. What about g prime of x? Remember, g prime of x, we're going to have to integrate it, so we want something that's easy to integrate. Well, if you remember from our earlier example, I have no idea how to find the integral of log x. Well, at least I don't have a simple rule to find the integral of log x. I know I could find the integral by using integration by parts, but I don't want to do that. Because it's complicated, something's multiplied by it, I don't know how that's going to affect it, and it's not going to work. So I think g prime of x here is going to have to be x squared. it's got to be x squared, which means that f of x is going to be log of x. Now, I'm not too worried about log of x, because that means that f prime of x is going to be what? It's just going to be 1 over x. But g of x is going to be the integral of x squared, and that's going to be x cubed over 3. So I'm a little worried about that, but let's see how it goes. Why am I worried? Remember, while I'm making this thing is going to become more complicated. I'm going to have to plug in something into there that's more complicated than x squared. It's x to a higher order, x to the power 3. But let's see. So f of x, we've got log x. And then, we always want to make it pretty, so I'll put the g of x, x cubed, in front of it, and then I'm going to make it even prettier and give it like a common denominator. Put the 3 at the bottom of both, so it looks very nice. Looks easier to work with that way. Minus the integral of what? It's the integral of 1 over x multiplied by g of x, which is x cubed over 3. dx. Let me save a little bit of time. I'm going to duplicate that and move it down here. Now, I can rewrite this just a little bit over here. I've got the x. That's going to cancel out, and that's just going to be a 2. So I'm going to have, that's going to be gone, and I'm going to have x squared over 3. And, this term's got a little more complicated, higher order, but at least I know how to find the integral of x squared divided by 3. And so that's what I'm going to do next. This part of the equation doesn't change, so I can just copy it like that. Now I want to take the integral x squared. I add 1 to the exponent, so I've got x cubed, but I also have to add the exponent plus 1 to the denominator, so I'm going to have x cubed divided by 9. And this time I won't forget to add the c. And so there is my answer. This is, according to integration by parts, this is the integral. But you know me, you know your instructor, Professor Robert. He likes to prove that that is indeed the answer. So why don't we take the derivative of this thing with respect to x and see if we actually do have, if we really do have the right answer. And to make things a little bit easier, I'm going to add a common denominator. Before we take any derivative. So I'm taking sort of the derivative of this whole thing. Now we get 9x squared log x. I have to use the product rule, plus 3x cubed divided by x minus 3x squared. And this whole thing is divided by 9. We can see that, leaving that part the same, I've got an x and an x, so this is going to become a 2, and that's going to be gone. I've got 3x squared minus 3x squared. This whole thing is going to be over 9. Those sum to 0. 9x squared log x over 9, and that's just equal to x squared log x. There's my derivative of the integral that I found. What were we starting with? Well, that's exactly what we were starting with. So this is the correct integral, and integration by parts was able to find the integrand for us.